This is Robert Klob, and this is Designing, Planning, and Building with ICF. Robert, go ahead and take it away.
Thank you, Dennis. So I'm going to go through, I have about 80 slides to go through, and I'm going to go through them pretty quick. What I would like to do is either put your questions in the chat or write them down, and I will take as much time as we need at the end of this to go over your questions. And if I need to go back to slides to talk about them, not a problem. But if I stop at every slide, we'll be here until tomorrow before we get this thing done. So with that, I'm going to start. My name is, again, as Dennis said, my name is Robert Klob. I'm president of Robert Klob Designs. I've designed or consulted on over 400 ICF structures in 30 states and 14 countries. I'm a certified installer for several ICF systems, affiliated with Energy Star. I have regular articles in regional and national magazines, and I was on the development committee for the PCA 100, which is the above ground concrete wall code. It's the backbone of the ICF code. We'll talk a lot more about that later on. I'm also a planning and zoning commissioner in my local county here in Arizona. Today we're going to talk about what are ICFs and what to look for in designing with them, proper design, selection, and detailing for the systems, safe rooms and disaster resistance, understanding the codes and requirements, thinking outside the box, that'll make sense later, and different resources for you. And then at the end, we'll go through just quickly some pictures of projects that you might not think are typically would be an ICF home. So what are ICFs? Why should I build with them? Oops, I lost my screen here. Sorry about this. There we go. So what are ICFs? ICFs are typically the most common in the market are these, they're called flat panel or white blocks. They are EPS styrofoam that have concrete goes in the middle. There's another variety that's also listed in the building code. It's called a waffle grid ICF. It is still with the EPS foam, and you can see the concrete goes almost like a waffle. It goes in tubes throughout the structure rather than a continuous core. Then there's a gray block, or sometimes you'll see referred to as ICCF, which is insulated composite concrete form. What they do is they grind up EPS beads, mix it with concrete, and form these blocks. They are recycled and they use less concrete, but they have some other challenges as well that we can get into if you need. Why ICFs? Right now, ICFs are one of the fastest growing construction areas in the market today. They meet or exceed all the green energy requirements or green and energy requirements. It's at least a 2-hour firewall doing nothing to it. Structural integrity and disaster resistance for tornadoes, hurricanes, earthquakes, and fires. It's mold and termite resistant. Fewer callbacks after construction due to less settling, less cracking, less structural challenges. Fewer subcontractors and materials because your ICF wall is it's your frame wall, it's your sheathing, it's your vapor barrier, it's your insulation, it's kind of everything all in one shot. And the other thing too is more and more consumers are understanding ICFs and researching them and seeing them out in the wild and requesting them. The biggest thing that people need to understand with ICFs is all they do is they give shape to the wet concrete. They're a form. They hold the concrete. They don't contribute to the strength of the building. The concrete does that. The forms themselves do not. As it relates to codes, ICF buildings are reinforced concrete structures, as noted in ACI 318, that any of your structural engineers, they all like this chapter. It's also, ICF buildings are fire resistant. By themselves, as I said earlier, ICFs are a 2-hour rated wall. You put 5/8 type X on a 6-inch core wall on either side, and you now have a 4-hour rated wall. It's pretty easy to even get as high as 6 hours, for some of my uh, some people that do multifamily work. If you do, speaking of multifamily, if you do that work, type 3 buildings can often be larger because of the fire resistance. They can also be taller. We can sometimes add a whole nother story onto projects. The only construction requirements for type 3 construction is non-combustible exterior walls, and the exterior walls to be a minimum 2-hour rating. And ICF walls meet that all day long. All 6-inch walls are naturally a 2-hour rating. As far as bearing capacity, the capacity of a 6-inch concrete wall is 5 to 6 times that of a 2x6 stud wall. In addition to the shear wall, it's 10 to 20 times stronger than what you'd find in traditional wood frame plywood shear. Building codes. In the International Residential Code, older codes have it as R611. The newer codes, it's changed to R608. In designing with these block systems, you're going to want to look for the code approvals for each system, like from, example from Intertech or an ESR number. And the PCA 100 above ground concrete wall code is kind of the fallback that the IRC calls out. Understand the prescriptive code. I'll go through in the next slide. And you need to make sure your building departments are familiar with ICF design elements. Sometimes they're not, and it can be a challenge, but usually once you show them, hey, look, it's in the code, that usually simplifies things for you. Over design is a common issue. I see this all the time. I get probably 3 to 5 times a month, I get projects sent to me that are either too thick of a core of concrete, too much rebar. The design professional, be it the designer, the architect, and or the engineer, just didn't know what they were doing. And I've had projects where we've cut tens of thousands of dollars out without changing the design. All we did was change the design of how they designed the ICF. As far as the prescriptive code in the IRC, if you're comfortable with doing, without a structural engineer, you're allowed to do so, as long as your structure is less than 60 feet in plan dimension, 10 foot tall walls with a max building height of 35 feet. You have floor loads of 10 PSF and roof loads of 15 PSF, 2-foot overhangs, and you can see the wind and seismic categories as well. If you're inside all of those realms, for the most part, you can design without an engineer. If you exceed any of those, then it kicks it into either the PCA 100 or the ACI 318, which are basically identical codes. Here is the actual code from the IRC. As I mentioned earlier, 608. 608.2 talks about exactly what I just mentioned. Now, my friends in California, understand California has a provision. You can design all day long with wood frame and masonry homes that straddle the San Andreas Fault, no big deal. The minute you say you want to do an ICF home, it is illegal, even from a design standpoint. You cannot even design it if you're not a California registrant. That has been pushed back by the state board. So why design with ICFs? It gives you a complete building envelope design. So we can see, starting at the bottom, we have EPS insulation below grade that creates that thermal bridging from entering into a slab or a crawl space. We have a continuous insulation on either side of the wall, and then we can take and get the ICF manufacturers actually sell billet insulation that we can continue up like in a heel truss to the underside of the roof deck. And so you get that continuous wall insulation from your footing to your roofing materials. We also don't get the thermal bridging in, such as basements or second floors, because again, the ICF has the EPS, the insulation on either side of the concrete. And we can also get creative with, like in a basement scenario where you have an 8 or a 10-inch thick or core wall, we have what they call a taper top, which is a flared, the inside of the foam is flared, so it gives a little bit additional concrete that we can put a pressure treated block, and then have our floor trusses, either the top chord or the bottom chord of the floor truss, rest on that, on that ledge. So taking away the need for ledgers, and it's also kind of helps with that transition between the two core sizes. After COVID, one of the exciting things that happened with the ICF industry is wood frame went crazy in price. It's come down some, but still not where it was. ICF has gone up a little bit, but nowhere near what wood frame did. So we are almost a wash in building with ICF. So where this is important to your clients is, in Phoenix here, an average energy bill for a 3,500 square foot home is about $350 a month. That same energy bill for an ICF home is 105. So if your costs are the same, but you're spending half as much or more on your energy bills, you have a net income, disposable income for your clients of another 200 plus dollars a month. And I have some analogies where I've shown where even if it does cost a little bit more for your ICF construction, this offset combined with your maintenance offset actually does every month. It's still cheaper, even though you might be spending, your clients might spend a little bit more, in construction costs. Where to find your ICF customers? Local ICF installers and distributors are coming up all over the country all the time. ICF manufacturers is an area where you can find who those installers and distributors are, and they also have their own manufacturers reps. Home shows and trade shows, another great location that a lot of the ICF companies are advertising at. Any of your local green building groups typically have them as well. Unfortunately, rebuilding from disasters. This is an area where a lot of people are looking at ICFs as they rebuild when Mother Nature comes calling. And then to advertise. A lot of people don't know. Advertise to your customers. Show it as an option. They might not have ever thought about it, but if you can show them the benefits, it might be an area where they'd be willing to investigate. So the specifics of the design of the block itself, typically for your above ground work, we're going to do with a 4 or 6 inch core. That's the center, that's the concrete thickness of the block itself. The 4 inch core uses less concrete, but we can have some challenges with consolidation. Just not a lot of room for the concrete to move in the wall itself. 6 inches use a little bit more concrete, but it's easier to work with, and it is the most common found in residential construction. 8 or 10 inch is typically found in your basement and commercial walls, and that's usually specified by a structural engineer. Here's one that catches a lot of people off guard. The EPS thickness of the block you specify. Each manufacturer is a little different. Some of the EPS thicknesses are 2 1/4 inches, 2.5 inches, 2 3/4 inches, 3 inches on either side. So you have 2 layers of that EPS. You could be off. You could have a difference of a half to an inch on your overall building layout. So when things get laid out in the field, if you're off by half an inch at every corner, you can see where problems could arise. So understand exactly the block that you're going to be specifying in your plans. Tight lots and setbacks need special attention because of the thickness of the wall. You want to make sure that nothing is going to encroach over a setback line, causing additional issues. Design clearance need to be accounted for, and I'll show you this in a detail later on, especially if you're going to be converting maybe a wood frame design to an ICF design. The other big one people need to understand is square footages. A 6-inch core ICF is roughly 10% of your floor area. So those people that work on square footage fees, sometimes your clients will come back and say, wait a minute, you're padding extra square footage in here, and you have to show, no, here's the area of the ICF and here's your floor area. So just be cognizant of that as you're designing to keep the client aware. ICF brands. There's all these and about 25 to 30 more in North America alone. ICF Builder Magazine has a great resource that's showing the majority of ICF brands. And the great thing that they've done is you can find the manufacturer, and it'll tell you who has code approvals, the ICCES reports or an Intertech report or something like that. Quick and easy to find, somewhat which are the better brands to work with, and what regions that they operate in the country. So incorporating the appropriate system into the plans and details. This is critical, and I'll explain exactly why this is so critical in a few minutes. You can see the ICF walls are graphically represented versus the frame walls in this design. So there's no question out in the field. There's no way one's going to get missed over the other. Incorporating into your details, showing exactly how the ICF, in this case, how the truss and the ICF come together. These aren't block details. These are ICF details. They're similar, but they're not the same. Same thing with your footings, door and window locations. There's a lot of different parameters that we have to look into. When I was talking earlier about being cognizant of the thickness of your EPS, here is, I have clients, they bring me stock home plans all the time. They buy online, but they want an ICF home versus a wood frame home. So I get these standard bathrooms that we've all done a million times. What I have to be careful of is I go from a 2x6 wall to an 11.25-inch wall, but I still have this same tub that I want to fit in here. That's one of those slide in, tubs that you can buy all day long that has the tub surround and so on. We don't want to have to go to a custom shower because I didn't take into consideration the thickness of the walls. So these walls have to grow to the outside, but sometimes if they grow to the outside, if you're talking about a side yard, that could create challenges in a setback environment. So you have to get a little creative on how these walls lay out. Be careful about that. Here's a door window head, and slab connections, stucco connections of interior framing walls, utilities, and I'll show you some pictures of that in a minute. So this one, poor ICF design. This is one that is a recent project, and some of you in the residential design group might have seen my rant about a month and a half ago about a design professional that specified an ICF home. This note right here is all the detail that he provided other than graphically showing an ICF wall. There's nothing in regards to the concrete mix. There's nothing in regards to the reinforcing. There's nothing in regards to anything. The contractor was left to make a lot of assumptions, and now there's problems in the field after the house was built. It's gone to the lawyers, and I'm probably going to have to testify against both the designer and the structural engineer, who there was a structural engineer that did a portion of this project, but neither followed the codes that I just mentioned. And they got it through the building officials by saying, hey, we'll take care of it. And it didn't get taken care of. And there's potentially, hundreds of thousands of dollars in lawsuit settlements that could come out of this thing. So make sure that, you're properly detailing things so a contractor can build it. It protects the homeowner, but you got to protect yourself too. We've had, a lot of presentations on liability and E&O, and this is an easy way to open yourself up. ICF decks are a popular area that we're seeing a lot of, the horizontal concrete decks, floor decks. Utilities, we channel out the EPS, and we can put in our utilities with, in those channels, whether it be just the Romex, we do piping, and then we can come back with expansive foam and fill it in. All the plumbing run it in the EPS. Do not run it in the concrete. The code says you can, but what do you do in 10 years if the owner wants to change something or add an outlet and everything's encased in concrete? It becomes a huge mess. Ensure the pipe will fit. If we have 2.5 inches of EPS and we're going to put a 3-inch vent stack behind a toilet, that's not going to fit. So we either got to pull up, fur out this wall, or we have to bring that stack up in an adjacent, wood frame wall inside the house. And to channel the EPS, they can use a hot knife, saw, chainsaw, router, pretty much anything that'll cut through the foam. Fiber versus rebar. This is something that's come on strong here recently, in the last 5 or 6 years. Rebar historically has been the go-to. Now we're getting these little stainless steel pins. They can replace most of the horizontal rebar. It saves a substantial amount of time in the field. The engineer specifies the batching. You put in so many pounds per yard, and it's done at the concrete batch plant before, as the truck's rolling down the road coming to your job site, it's mixing it up. They also have their ESR report and approval, so it does make it easier when you're dealing with engineers and building officials. Basements. The ICF wall provides your moisture barrier, insulation, retaining, all in one product. We still have to cover the inside with drywall due to the code's flame spread ratings, and some building departments, for those that do unfinished basements, that has been a challenge. Just got to cover it with drywall. Sorry. The outside gets usually I like to do like a dimple board, and we can do a mastic peel and stick bituminous membrane on the outside wall, or there are some very good paint on waterproofing that can be done as well. Bucks, not these. These are window bucks, door bucks, essentially door framing, window framing. Often, historically, we've seen wood bucks. The challenge with them is they're prone to cupping and thermal gaps if they're not installed correctly. We get a lot of thermal bridging, but they're easy to get on, onto your job site. Vinyl bucks are very popular as well. They can be block specific, and so you get the exact thickness that we talked about earlier of the block itself, but you do have some issues with thermal bridging, and typically they're special order. The ICF industry has come out in the last 5 or 6 years with their own EPS bucks. These work great. They're easy to install. You don't get the cupping issues. You don't get the thermal bridging issues. You can see in this scenario, they have these webs that are inside. These can be attachment points to screw door, windows, framing, whatever it is that you want to attach to those. The challenge can be with curves. This manufacturer allows it, other manufacturers don't. So you'll want to talk to your ICF rep to make sure that it's not going to be an issue. Once the bucks are in place, you need to brace them. As you pour the concrete, there's loads, there's substantial loads that are applied, but once the concrete's cured, then all this bracing can go away. You'll notice the bottom of this is open, and this allows us to pump the concrete into the underside of that wall, and to be able to run our vibrators in and get the consolidation underneath these window openings as needed. ICF bracing is critical. This will ensure that you have straight walls. The great thing about it is it gives your catwalk. So for stacking your blocks, for running when you're pumping the walls, for running your vibrators. Also, if you notice in this bracing, you'll see these little handles. These are turnbuckles. So we can put a laser on these walls and we can dial them in or out depending on, how plumb, if they're out of plumb, and we can make these walls just dead nuts on. Another interesting one that's come through recently is uh, is a bag type ICF footing. Put this on the bottom of your uh, in your trench, and you're able to pour your walls and your footings all at the same time, so you don't have to do multiple pours. Safe rooms and disaster resistant homes. This is where a large portion of my business comes from. Are people that want, maybe live in disaster prone areas, tornadoes, hurricanes, and so on. Safe room design has become very popular. So one of the things that I try and do is, if I know that we're in an area that maybe is tornado or hurricane or fire prone, then I'll integrate these safe rooms. In this particular house, I did it as a pantry. We have a FEMA rated door. We have an ICF wall all the way around. We did a concrete deck above, but it's right off the kitchen. It's able to be used daily use as the pantry. Those big FEMA rated doors are big, heavy steel doors, not always something ideal for what people want. So in this particular case, what we did is we do have the FEMA door here, and we put a barn door over the top. So it's able to close off the pantry, but easily be able to have access to it on a daily basis, for that use. So it doesn't look like a storm room. Why use ICFs? Well, one example, this is from Hurricane Irma a few years ago, hit the Fort Myers area. This was a home that I designed that's was under construction at the time. The catastrophic damage occurred by losing this piece of trim. Nothing else in the house was damaged. And in fact, one of the neighbors lived in a 1970s wood frame home. As the storm came in, the winds kicked up. They were a little scared. My client had told them, if you guys have any issues, we'll leave the back door open. Feel free to come, and weather the storm in our house. And they ended up doing that. And they spent 3 days camping in this concrete home. And the mom of this family sent me a message on Facebook thanking me so much for designing a home that her family was protected in. And the next home that they designed, they will make sure it's ICF. Hurricane Michael hit the news several years ago. Complete devastation to Mexico Beach, Florida. Everyone talks about all the damage and destruction to homes all around. Something that's interesting, this home was ICF. And the home behind was wood frame. The concrete home protected the wood frame home, whereas all the other homes around were completely destroyed. Hurricane Katrina in 2005, as it hit the New Orleans area, washed homes completely off their foundation. You can see, yeah, it had damage, but if you were inside that home, you probably survived. If you're in this home, you might not have. Southern California wildfires. This is a subdivision that these homes have been rebuilt 3 and 4 times, due to fires in Southern California. These 3 homes, after one of the fires, were rebuilt with ICFs, and you can see the next fire that came through, what happened. This is an F3 tornado in Wisconsin. You can see all the neighboring homes here. This home lost part of the roof. This one, same storm, huge tree fell on it. It damaged the roof. This was a drunk driver. There's actually another case that this literally just happened about 3 weeks ago. I think in Atlanta, but I'm not positive. In this case, a drunk driver was doing 90 miles an hour down the road, hit the curb, went airborne, crashed into the corner of this house. this corner was a bedroom of a little 10-year-old girl was asleep in it. You can see the stucco damage that occurred, killed the driver, but the little girl was safe. This is a boulder in Utah, rolled down the hill, hit an ICF home. Still had to be rebuilt, but if you were inside, you still lived. Termites cause most damage of any other thing in America. ICFs have a barrier that can go between the block layers that termites cannot penetrate. Building codes. So this is where, as you're designing and working with your municipalities, they need to understand it's a pre-engineered system per ACI 318. Hopefully you can find an engineer that's familiar with either ICFs or ACI 318. Sometimes they balk at designing an ICF, but if you tell them, wait, all it is ACI 318, they're, oh, we know that, we're good. It's concrete, that's all it is, nothing special. Mechanical design. One of the great things about an ICF design is we can reduce the size of our units by somewhere, depending on your climate and the design and so on, anywhere from 30 to 50% in some cases. The other thing that ICF homes do is they maintain and they control your temps for longer, so you don't have less cycling of your AC units. It is critical that you get at least a manual JS&D design of your home. Typically, we're including either ERV or HRV systems as well, just because these homes are so tight. And in your electrical design, you want to make sure that it's taken into consideration as well, because we have much smaller AC loads. Energy efficiency. How am I doing on time? Energy efficiency. A traditional wood frame home, R14, barely meets the code. In some cases, doesn't meet the code anymore. That gives us a true, wall R value of about 11.5. If we come into a 2x6 frame with a 1-inch rigid insulation on the outside, we get an R20 plus an R5, and it gives us a wall performance of about R19.4. A 6-inch ICF concrete as it sits, not including the thermal mass, just the EPS foam, puts us right about at 23.36. Changes a little bit depending on the ICF brand that we're using, anywhere from 22 to 30, depending on which brand and the thickness of the foam. Now, the more important part of this is getting away from the R values is equilibrium. How long does it take for energy, heat, to pass through that object to equal out on the other side? In a traditional wood frame 2x6 with R20, we can get equilibrium in about almost 5 hours. Our 2x6 with R24s, 12.5 hours or 12.75 hours. Our 2x6 with expansive foam and rigid is about 54 hours, but the ICF with the concrete gives us 144 hours. And I asked a friend of mine a few years ago about that exact thing. He's a PhD from MIT. His name's Peter Vanderwerf. He's written numerous books on concrete design, concrete homes, and so on. His exact words were, that many hours of direct sunlight means the earth stops spinning. We have much bigger issues. So thinking outside the box, what are some other areas, building homes, building commercial projects? That's easy. What are some other areas of ICFs? Pools are huge. I have more pool companies coming to me every year asking about adding ICFs to their design in the last 3 years than I've ever had before. They essentially create an insulated wall for a pool. In a lot of areas, they can extend the shoulder seasons by a month by doing nothing else other than installing ICFs. As a designer, we can integrate curved walls really easy. Doesn't have to be a big box. We can do fun things. We can do weird angles. Earlier, I talked about safe rooms. I had a client he was a medical doctor in Jacksonville, North Carolina. He said he wanted a safe room on the side of his house with a concrete roof, concrete walls. And I said, that's awesome. Hurricane Sandy had just come through that area a few years prior. He said, yeah, it's not for Mother Nature. And I said, well, yeah, that's good having a space for to store valuables or guns or whatever. That's good to have too. And he said, yeah, it's not for that either. And I said, well, now you piqued my interest. What's it for? He said, it's for the zombie apocalypse. And initially I laughed, and then I realized he's a medical doctor with the military. He probably knows things I don't want to know, and it wasn't funny anymore. So I get them all. Exposed concrete. Those people that want to have that, you know, more industrial look. We can do a single face ICF. What they do is they have the EPS on one side, and they have the like a plywood panel on the other. They pour the concrete and they remove the panel. This also works well for fire rated stairwells, elevator chases, shafts, things like that. SIPs and ICF. I don't know if my friend Andy is with us on this one or not, but uh, do a lot of SIP roofs with my ICF walls. It just gives that incredible thermal envelope. Here's another home that was designed with SIP roofs. Some resources for you. ICF Builder Magazine is a monthly magazine that features all about ICF's manufacturers and products. The ICF Manufacturers Association, a lot of the manufacturers have got together, formed an association to be able to put out marketing details, answer information as a collective rather than as an individual. The Portland Cement Association has teamed up with the NRMCA to offer different programs. The NRMCA has a great program, especially if you're doing multifamily projects, where they will take your plans for free and they will do a cost analysis of what the cost would be for as designed if they're wood frame, and what the cost would be for ICF, and then what the 10, 20, and 30-year lifespan costs would be for that. And that's a free service that they offer. All you have to do is send them your plans. And last but not least is always Google. I'm going to flip through some different projects. This is a home that was all ICF home, concrete deck, concrete walk deck, concrete roof deck. We've also integrated fire rated shutters that will come down. This is in a mountain area prone to wildfires. Here's a little tiny chateau in Canada that was done. I think it was about 60,000 square feet, if I remember correctly, with the floors, the outbuildings, and basements. This is a beachfront home in Florida. This is one of my projects here in Arizona. This is at a private airstrip. The house itself, nothing special. What's crazy and incredible about this is this hangar was designed in ICF. This is a 42-foot wide airplane door. All ICF headers. There is no steel in this, other than the rebar. Not a big steel beam. So getting big spans are great. So those that want to incorporate big window walls, the big lift and slide windows, things like that, easy to accomplish with ICFs. This is a church that I'm working on right now. We're getting into 80-foot spans in the sanctuary. This is a home in Paradise Valley, Arizona. You can see all the curves. The pool, everything was done with ICFs. This is a home in Texas. This is actually a home in Great Britain. It won some design awards a few years ago. It's a smaller home in Southern California. And in conclusion, the world is evolving to create more sustainable buildings. Communities now have access to not just traditional materials, but some of the best building technologies ever available. With the current climate conditions and recent catastrophic damage from Mother Nature, ICFs will provide a safe and affordable alternative for many of your clients. So with that, I'm happy to take any questions. And
Thank
there
you,
is my
Robert.
contact information if anybody wants to reach out to me directly.
Thank you, Robert. I appreciate this. We do have one question to start off that came in the chats. Came from Audrey. Hi, Audrey. Uh, it's how do you manage clearances if plumbing and electrical is run in the foam, continuous nail plates, and how do you support the wires per code?
So I'm going to go back to my slide here showing the
Audrey always asks good questions.
yeah. And it's actually where once your plumbers and electricians do an ICF project, they'll probably be asking to do more because a lot of those issues you don't have to worry about. So with electric in plumbing, everything just gets channeled out. Romex, all you have to do is push your Romex in 3/4 of an inch. You do not have to do as long as you go beyond the 3/4 of an inch, you do not have to do the nail plates like you would in wood frame. To hold it in place, just a little bit of expansive foam will hold everything where it needs to be. As far as plumbing goes, the biggest challenge I run into with plumbing, anything under 2.5 inches is usually not a big deal. It's when you get in anything larger. Typically, what I like to do for, even though this shows a washer box, I don't like to put my washer boxes in an ICF wall, and also, of course, dryer boxes, vent boxes. Electrical panels, I don't like to have on the ICF wall, even though they kind of need to be there on the outside, but we end up having to fur those out or we'll create a chase for those. As far as plumbing goes, what I typically do for my washers, for toilets, things like that, that might have a 3-inch box or 3-inch vent pipe. If you think about a toilet, often you have a back wall and you have a wall that's 90 degrees perpendicular to that wall nearby often. Try and run your vent stack in that frame wall instead of the ICF wall. My friends that live in cold climates, a lot of you already do things like that, trying to keep your plumbing stacks out of exterior walls. So some of that's already in a lot of people's design psyche anyway. But that's really the only issues that I find where I try not to put the items in the EPS.
Right. So Ethan Oriens has a question. He says, any resources you recommend to view different wall conditions or drawing details? I've always been curious how to attach a SIP roof, as that's what I primarily design, and exterior finishes from steel or composite siding to masonry or stucco.
So the ICF manufacturers several of them have really done a good job of creating details, construction details, wall sections, individual details for a lot of different attachments. One of two of my favorites that I think have the largest quantity of details. I'll be honest, not always the best quality. I have to go back in and edit most of them, but at least gets me going in the right direction. Is Fox Blocks and Build Block. They both have great resources on their website for details. I think both of them you have to. There's a what they call a paywall. You have to fill out your your name and email address, phone number, whatever, to get to it. But they don't. They're pretty good about not harassing you with a bunch of inundate you with a bunch of emails. So once you get past it, then you can download all of their emails, all their their technical information, code information, pretty easy. If you have a specific situation that you're trying to get, working with one of the local distributors and or one of the local installers, more often than not, they can get you answers. And, I always put out there that if you really start running into pun intended, a brick wall, reach out to me. I know most of the players in the business, and I can usually point you in the right direction and get you some answers.
Awesome. So Christian is asking, what should you do differently, if anything, if the building is in Florida or Alaska?
That's the great thing about ICFs is there really isn't much different that you have to do, other than you know, you know your foundations in Alaska are going to be deeper than they are in Florida. Um, as far as the wall itself, it's going to meet all of the energy requirements in both. And to that point, there is a lot of ICF construction done in Alaska. I actually did a project this summer for my brother-in-law. He up in the Kenai area. And there's some very good builders that are building with ICFs there, and really not running into a lot of issues. I know the project I worked on, there wasn't much pushback from the building official. The energy, the insulation in the attic, and creating that continuous bond, and that continuous envelope was critical though.
I have a question that the whole time through I was thinking about this.
Yeah.
Is if I have a multi-story house, 2 stories and a basement, how do I put in the floor system? I mean, I saw how you did it for the basement to the first floor, but like the second floor, how does that work? Do you just ledger board or?
Second floor is, yeah, just like that, just a ledger board.
Okay, that's what I was curious about.
I don't remember exactly where that one was, but yeah, there's a ledger board, and actually Simpson has a great, it's called an ICF VL. It embeds into the concrete, or into the ICF on the concrete side, before the concrete gets poured, and it has 2 little prongs that stick out that, there's a or that stick through the concrete into the concrete area, and there's a plate that goes on the outside. That with that, you get a second piece that attaches to it and screws to it as your anchor point for your ledger board. So a lot of that design's already been done for you.
That's awesome. Because that makes me want to do more ICFs now here in Maryland. I gotta find some contractors I can use.
Looks like Audrey had a follow-up question about or she gets called on 1.5 inch clearance to the wires. Yeah, that happens sometimes. And if you have 2.5, 2 5/8 foam, what a lot of contractors do is they take and they route out all the way to or near the concrete core. So, if you have a 2.5, 2 5/8 foam, you can push your Romex all the way into that, and then then there's no problem with the 1.5 inch clearance.
Awesome. Any more questions? Go ahead and let me know. Even unmute yourself and ask it. However you want to do it. I want to thank you very much, Robert, for doing this.
My pleasure.
For our little group. I think we had a total of 20 people at one point here, but I know that a lot of people sign up for this so they can get the reminder that the link comes up on YouTube so they watch it later. So
yep.
I know we had almost, I was telling Robert earlier, we had almost 80 some people sign up for this. It was tremendous. So I definitely want to do more products like this. Now I need to get somebody who does SIPs.
Andy Roll.
Okay, I'll get him in there.
Andy's in the EA group. I don't know if he's in our residential group,
I
but
think he is.
he is Andy's my SIP guru, and actually I owe him a phone call on a that church project that I was talking about. We might do a SIP roof on the sanctuary of that church. Um, it works real well with you know you just get a great thermal envelope when you
Right.
combine the two.
Yeah, I know around here we get a lot of because of the hurricanes that come through. They come through with tornadoes,
Mm-hmm.
and we've had a couple of earthquakes here on the eastern shore of Maryland, which
Yep.
I never would have thought we'd have had those. But that said, I know that there have been several places that have withstood, and they're usually concrete, some form of concrete is what stands. The rest of it washes away. So,
Yeah, I would say probably 20 to 30% of my clients over the last 10 years are either rebuilding, or sometime in the past they've had Mother Nature destroy a home that they were in, and this is going to be their retirement home, and they want to make sure that Mother Nature can't do that. I'm actually, on a personal level, we have a family cabin up in Colorado that um, I'll be hopefully submitting for permits here in about sometime later this month. That cabin it backs up to the Rocky Mountain National Park. The Colorado River forms one of the property boundaries for this property, and it was completely destroyed in a fire a couple of years ago. And we are rebuilding with SIPs and ICFs.
that's awesome. So we are at an hour, close to it.
Okay.
It's 5:27. If anybody has any more questions, we'll take one or two more questions. Um, Let me know real quick. Otherwise, we're going to go ahead and thank Robert and go ahead and end this. And then I will get this up on YouTube as fast as I can for the link.
I'm
Um,
going to switch back to the end here that has my contact information if
yeah,
anybody needs to reach out to me. Go on. Making the crazy thing makes me go through, click all the buttons here.
yeah. This has been extremely helpful, and I really appreciate it. Robert is also one of our admins in the group, so uh, if you ever want to know why our group is so good, that's why, because we have good people there, admin. Um, I appreciate it, Robert.
The other thing
Uh,
I will add is I also admin the two largest ICF Facebook groups. One is called ICF Builder Group, and another one is called ICF Insulated Concrete Forms. And both of those have about 10,000 members. So there's quite a few people there, most of which are individuals looking for information. There are a lot of installers from around the country, and it's also a great resource for people, looking to get into it. And it can be a great resource for people looking to find design work as well.
yeah, we might when I might run a thing where we're showing those on the group for the designers who want to get on there because that's a good resource for us. It's a good place for us to be able to talk to other people who do this all the time,
Yep,
and it's a great place for us to share what knowledge we do have as well. So,
exactly.
all right. Well, it looks like everybody's getting ready to head out, so we're going to go ahead and end this.
Thank you everyone
Um,
for attending.
yes, thank you very much. And if anybody has any other questions, you have his email address there. You can always do that. You can get with him on the residential design group, and I'm sure that he can answer from there as well. Other than that, I think we're good. I'm going to go ahead now and we're going to go ahead and end this. So thank you all very much and have a great day. And I'll see you on the group. Thank
Thanks,
you very
everyone.
much, Robert.
See you, Dennis.